Dear learners, welcome back. The experiment we are going to discuss today is load test on three-phase alternator. This is the circuit diagram of an alternator. In this we have two sections. The first section is called as a prime mover and the second section is called as an alternator. This alternator is coupled with the prime mover, because the alternator will not run by itself. It needs an additional source. That source is called as a prime mover. The prime mover which we are using here is DC shunt motor. So this is the three-phase alternator, prime mover and alternator nameplate details. The alternate nameplate details is given here. Capacity is 3 kVA, voltage is 400 voltage, current capacity is 4.3 amperes. The prime mover, we are going to use a DC shunt motor, and watts is 3.7 watts, voltage 220 voltage, maximum current capacity 19 amperes. With this help of this prime mover, we are going to run this alternator. So this is your 3-point starter. The purpose of this 3-point starter is to reduce the inrush current. In this you have two rheostats. This is a field rheostat of motor. This is a field rheostat of alternator. The purpose of this field rheostat is to control the speed of a DC shunt motor. You can increase or decrease above base speed or below base speed. This is 1500 RPM. If you want to set the 1500 RPM, by varying this field rheostat, we can set the speed to 1500 RPM. This field rheostat of alternator is to generate the voltage. If we increase the voltage, we can gradually increase this. If we increase this field rheostat, the voltage will be increased. So this is your DC shunt motor and this is your alternator. These two machines are coupled. This is your alternator, this is your DC machine. This machine and alternator is coupled by means of a coupling medium. This part is called as a coupling medium. So connections are given as per the circuit diagram. Now we are going to, for this experiment, we have three types of load. This is called as a resistive load, this is called as an inductive load, and this is called as a capacitive load. All three loads are connected separately to a DPST switch. This is called as a TPST switch. This is the voltage generated from the alternator, and this connection is given to a resistive. This is a resistive load, is given to a DPST switch. This connection is given to an inductive load. This is called as an inductive load, and this is your capacitive load connection is given here. We are going to consider the three types of load: resistive load, inductive load, and capacitive load. Now we are going to switch on the supply. This is your MCB. Switch on the MCB side. With the help of a 3-point starter, we are going to start this motor. Gradually we are going to increase this. So motor has been started. Now we have to set the speed. The speed of this motor is 1500 RPM. We have to set the speed 1500 RPM by varying this field rheostat. By using a tachometer, we are going to measure the speed of this motor. Here the speed 1340 approximately. So now we have to vary this field rheostat. If we vary this field rheostat, the speed will be increasing. The speed is 1490 or 1500 RPM it has been set. This is what is required. After that, we can remove this tachometer. So the machine is running at 1500 RPM. So this is your field current, this is your generated voltage, and this is your load voltage. Here the load has not been on, it is in zero condition. It is 0 voltage, 0 amperes has been shown here. So the field current is approximately, it is 1.15 amperes. So now we have to generate the voltage. Here the alternator voltage is 400 voltage is the alternator voltage. We have to set this voltage. For this we are going to use this field rheostat of this alternator. We have to vary this rheostat gradually so that the voltage will be increasing. This is your voltmeter. The voltmeter can be increased. If you vary this field rheostat, the voltage will be increasing gradually. We have to bring this voltage up to 400 voltmeter. In this voltmeter, we have to bring this reading up to 400 because it is connected. The range connected here is 600. So we have to set the voltage of 400 voltage. By wearing this field rheostat, we have to bring this voltage. This is your rated voltage of the alternator. After that, this is it. First that we have to take down the first set of reading. This is called as a no load voltage. A no load voltage, this is your field current. Your field current is 0.62 is your no load current. No load field current. 0.67 is your no load field current. And the generator voltage is called as a no load voltage. Is also called as a alternator voltage. The voltage here is 400 voltage. Here the load current is 0 because we have not started all the loads. All the 3 loads are in switched off condition. So this is it we have measured. We have to note down this reading in this tabular column. In tabular column, this is your load voltage, line voltage, phase voltage, load current. We have to measure this. So this readings will be given. This is your first set of reading. First set of reading is 0.67. 0.62 is your field current, 400 is your voltage, and 0 is your field current. And second set we are going to read. We are going to use the resistive load. We are going to gradually switch on the supply. So we have different switches available. Different switches are available. We have to gradually increase one by one. So this is your 2 amperes load. We are going to one. If you switch on this load, here the load current will be increased. This is your load current. Basically it was 0 amperes. Now it has been comes to approximately 3.6. So we have to multiply this because the range is 5 amperes are connected here. So it is multiplied by 2, gets us 3.6 is nothing but 1.6 will be your current. The voltage has been decreased. Gradually it is decreasing from 400, it is decreased to 350, 370 is the voltage, and field current will be somewhat constant. This is the first set of reading. Your second set of reading, we are going to again we have to switch on the load. If it increases, the current rating will be load current will be increasing, and the voltage will be still decreasing, and this is called a field current. This is how we are going to take the readings for your resistive load. Till the rated current of this alternator is 4.3 amperes. Up to this is the rated current of this alternator. Up to this we have to load this load current. 4.3 amperes means approximately we can keep this as 8.5. You can keep this meaning as 8.5. So approximately we get this as 4.25 will be your rating current. We should not load beyond this rated current. This is your first set of load. If you want to load the second load means we have to switch on this supply. We have to switch on the supply. Then if you are going to use the inductor load means we have to close this DPSC switch in this position. So this is your inductive load. We have to vary this inductive load gradually. So you can see your current will be increasing gradually. So for this condition, we are going to measure the voltage and your field current. We can load up to 4.3 amperes. So the current is gradually increasing. We are gradually increasing the load, inductive load. So for inductive load, we are going to increase it. So you can see this. If you increase this, if you increase the current, the voltage is gradually decreasing. You can find here also. So see the both conditions. This is your load current, this is your voltage. Both are decreasing. Voltage is decreasing, load current is increasing. You can see it. It is gradually decreasing. The no load voltage is 400. Now the voltage is 300. It is decreasing. The current is 3 amperes. Now the current is 3.5 amperes. 7 means because the connection given here is 5. So it is 7 means we are divided by 2. It is nothing but 3.5. So approximately the current is 8 amperes. Approximately the load current is 8 amperes. So the voltage is 250 voltage. We have to measure this voltage. This is your, what load is you are going to use is inductive load. So this is the way we have to take 5 to 6 rate of readings by varying this field this inductive load. Now we are going to decrease this load. Before switching on this supply, this current has to be reduced to 0. So it has been reduced to 0. The same way we have to open this SPST switch and we are going to use this capacitive load. So we have to close the switch in capacitive load here. So we have to switch one by one. If we increase the capacitive load, in this, remember this, the voltage will be increasing. The resistive load and inductive load, the voltage has been decreased, but in the capacitive load, the voltage will be increasing. So now we have to increase this, the voltage is increasing gradually. You can find here. So current is approximately 1.7. Here the voltage is 450. So now the amperes is 3 amperes, voltage is 456. And now it is 9 amperes, the voltage has been increasing. So this is it. We have gone beyond the rated current. So voltage increasing, so current load current increasing, and this is your voltage also increasing. Remember, again I repeat, in resistive load, inductive load, whenever you increase the load, the voltage will be decreasing. When you go with the capacitive load, the current will be increasing as well as the voltage also will be increasing. This is what is happening in here. After that, we are going to switch on the supply. So we have to come to the original position. So the load current should be 0. We have to bring the voltage to rated voltage. Now we have to open this CPST switch, and before switching on this has been reduced. The voltage has to be reduced to 0. Comes back to the original position. And we have to bring the field rheostat also to the original position. Now we have to switch off the main supply. So this is your load test on 3-phase alternators. In this we have 3 loads, resistive, inductive level. We have to note down this and we have to draw the graph also. So this is a tabular column given here. First one is your resistive load, second one is the inductive load, and third one is the capacitive load. Hope all have understood the readings of a load test on alternator, 3-phase alternator. Let's all meet in the next session. Thank you.